नमस्ते, सबको स्वागत है। इस वीडियो में मास स्पेक्ट्रोमेट्री क्या है, इसका प्रिंसिपल क्या है, मास स्पेक्ट्रोमेट्री अदरवाइज आल्सो कहता है मास स्पेक्ट्रोस्कोपी। इस इंस्ट्रूमेंट क्या है, एप्लीकेशंस क्या है, सबका डिटेल डिस्कस करेंगे, समझेंगे। ओके, ठीक है। बेसिक प्रिंसिपल क्या है? ओके, इन मास स्पेक्ट्रोस्कोपी, मास स्पेक्ट्रोमेट्री, the molecules are bombarded with a beam of high energetic electrons. Okay, ठीक है। molecules bombarded high energetic beam electrons। इस समय एक और दो इलेक्ट्रॉन्स निकल गया। Okay, molecules are ionized. The molecules are first ionized, and then you see, देखिए, the ions नहीं stable नहीं है। The ions formed stable नहीं है। Therefore, they are broken down into many smaller fragment ions of unipositive ions. Okay, ठीक है। चार्ज क्या है? द आयन्स +1। ओके, 3 ईच काइंड ऑफ आयन, देखिए, सेवरल आयन्स फॉर्म्ड। ओके, ईच आयन हैज ए स्पेसिफिक रेशियो ऑफ m/z रेशियो वैल्यू। z ions charge, each ion has charge z equal to 1. We have seen here they only form unipositive ions mostly, therefore then m/1 equal to m, the ratio is equal to simply the molecular mass of the ion. ठीक है। Okay, mass spectra is mainly used in organic chemistry. It is also used in forensic science, biochemistry, protein chemistry, and microbiology, in all the fields, physics, to find the relative abundance of isotopes, etc. It is mainly used in organic chemistry. It can give the exact molecular mass, molecular formula, and its elemental composition. And then how many isotopes, how many compounds are present in the mixture, and then to identify and distinguish two different compounds, impurities, analysis of fragmentation pattern, analysis of fragment, that is, each ion gives specific ions, that is fragmentation pattern, obtained to establish the structure of a new compound. It can also reveal the presence of certain structural functional units present in a molecule. Let us now see its instrumentation. This is the instrumentation experimental setup for mass spectrometry. This is the experimental setup. Okay, it consists of 4 major components. It consists of 4 major parts. One, ionization chamber. Okay, this is called ionization chamber. And second, this part is called accelerator, and this part is called electromagnet or deflector, and this part is called detector, then amplifier, chart recorder, and to computer. We have sample injector. The organic sample is vaporized and injected through this to the ionization chamber. Okay, let us now describe each component separately. Okay, let us first study the ionization chamber. What is the role of ionization chamber? Okay, so this is the ionization chamber. The vaporized sample is injected through this. Okay, and here there are high energetic beam of electrons. When the vaporized organic sample is allowed to pass through this, okay, they meet with the high energetic electron beams. Okay, as a result, the atom's molecules is ionized by knocking one or more electrons to give a positive ion. Okay, please remember, mass spectrometers are always works with the positive ions. Okay, the atoms or molecules in the sample are bombarded with a stream of electrons to knock one or more electrons out of the sample particles to give positive ions. Okay, now let us see the accelerator. What is its role in mass spectrometry instrumentation? So this is the accelerator. It consists of several charged parallel plates. Accelerator consists of several electrically charged parallel plates. What is its role? The ions passed through a set of charged parallel plates to accelerate the fragment ions. Okay. The ions are accelerated when it is passed through the accelerator charged plates. The acceleration speed can be controlled by the applied charge on the plates. Okay, then detector. The ions, after passing through deflector, hit the detector to produce current, which is then amplified. The ratio of mass to charge of each ion is analyzed by the computer and then plotted to give mass spectrum. So what is deflector? It consists of electromagnet. It consists of a powerful electromagnet. Different ions are deflected by the magnetic field by different amounts. Okay, by means of electromagnet, the different ions are deflected by different amounts. The amount of deflection by the ions depends on mass of the ion 1, charge on the ion. Okay, so M by Z ratio. Lighter the ions, more the deflection. Lighter the ions, more the deflection. So lighter ions are more deflected than the heavier ions. Then charge on the ions. More the charge, more the deflection. For example, ions with 2 or more positive charges are deflected more than ions with only +1 positive charge. ओके, ठीक है. अगले स्लाइड में मास स्पेक्ट्रोमेट्री के एडवांटेजेस, बहुत एडवांटेजेस है, सैलेंट इंपॉर्टेंट फीचर्स क्या है, सबको डिटेल देखेंगे. ओके, इट इज़ द मोस्ट एक्यूरेट मेथड for determining the molecular formula and molecular mass and its elemental composition. Okay, next, it is a microanalytical technique. Requires only nanomoles of sample to obtain structural and other informations. Okay, it requires only nanomoles of nanomolar quantity of the sample. It is highly sensitive and selective technique. Further, fourth point, it is a destructive technique because the sample is consumed during analysis. The sample is broken, so it cannot be reused. It is consumed in the analysis. Then, the mass spectrum of each compound is characteristic unique. Each compound gives unique mass spectrum. Therefore, it can be used as a chemical fingerprint to characterize the molecule or to identify the molecule in the sample. Let us now see the mass spectrum of ethane. In mass spectrum, the relative intensity of each ion is plotted against M by Z. See, the relative intensity is plotted against M by Z. So, mass spectrum plots the relative intensity of each ion formed against the mass by charge ratio. Okay. This is the mass spectrum. There are several fragment ions are produced. Okay. So, mass spectrum of ethane gives characteristic fragmentation pattern of several ions with the different M by Z ratio as evident from several peaks. There are several peaks. Okay, this is molecular ion peak M plus. The molecular mass of ethane is 30. Okay, because of isotopes you have 29, 31, etc. Carbon 13, carbon 12, carbon 14 and all. From the relative intensity, the abundance of isotopes and quantitative determination of the molecule in the sample can be carried out. धन्यवाद. फिर से मिलेंगे. सब्सक्राइब कीजिए, शेयर कीजिए. धन्यवाद.